Right, guys. Some paper one revision for you. Just check my pen is working. Yeah, okay, we'll write in red. That's fine. This isn't going to be one of the best videos I've ever made, but we'll get through it. So the first question: operations with decimals. Adding, taking away, multiplying, dividing, one of each. Just make sure for these, particularly for the adding and taking away, that you line things up properly. You know, that the decimal points are under each other, that you can put zeros in as kind of placeholders if you need to, and that you're adding those. I don't really have a lot to say there. Dividing, again, there's no issues with dividing. If we just do this last one here, 8.56 divided by 4 is 4 goes into 8 twice, 4 goes into 5 once, remainder 1, and 4 goes into 16 4 times. Just remember then to put the point in the same place in the answer. Okay, next, can I scroll down? Not particularly well, I'm going to do that way. Okay, multiplying with decimals. Just think about balancing how many decimals are in the question with how many are in the answer. So, for example, if we take this last one here, there's one number after the decimal point here and two numbers after the decimal point in this one. So that's 3 in total. So even though 8 times 7 is 56, 56 is only 2 digits, so, but we need 3 digits after the point. So we're going to need to add a 0. We always add the zeros at the start. Okay, so that would be 0.056. Or if we have a look at this one here, 8 times 1 is 8, but we need 2 numbers after the point. So again, we're going to need a 0 as a placeholder here. So 0.08 compared to here where that would just be 0.36 because 9 fours are 36. That's enough of that one. I think this is the first toughie that we just need to be aware of. A lot of people think that when you divide, the answer is always smaller than what the original number. But if you're dividing by a decimal, it'll be bigger because decimals are smaller than 1, so they go into 1 a few times. So if I was saying how many 0.2s go into 6, well, 5 of them go into 1, so the answer is going to be 30. However, a bit of a shortcut here is to go, look, I don't really want to multiply by decimals. Think of this as 3, but to make that 3, I've had to times this by 10. So I'll also times this by 10. So I keep the sum the same as long as I times them both by 10. Or here, to make this 6, which is what I want, I need to times this one by 100, 2 jumps of the decimal point, but I'll also times this by 100. So we end up with 6,000 divided by 6, which is much easier to work out 1,000. And one more. This one is as simple as this. Again, to make this 2, I need to times this by 100. Therefore, I should times this by 100, but it actually just becomes 6 divided by 2, which is quite simply 3. So think about the decimal that you're dividing by. How can I make it a whole number? Times 10 or times 100, do the same to the other number. We're on to question 4, estimating. Pretty simple, I think, for you guys. Just round in numbers. Look, any number that's bigger than 10 but lower than 100, like that, I would round to the nearest 10. Any number that's smaller than 10, I would round to the nearest unit. And the same there. Okay, if I was doing this, I would do 5 times 5, which is 25. 25 times 8 is 200, but I ignored that 0, so I still need to add that 0 on the end. And I want to quickly do another estimate. So just watch out, guys. So if the question says estimate, this is what you're doing. You're rounding your numbers to make them easier. This last one is the one that's most interesting to me, I think, for this exam. 40. Now, we've actually got a number here that's bigger than 100. So at this point, I'd be looking for the nearest 100. Nearest 10. And so a number smaller than 10, so nearest unit. So at the top, I have 8,000. And on the bottom, I have 80. Okay. Once we're into the dividing bit of an estimate, we can cancel zeros, right? Not like multiplying where I'm ignoring zeros and putting them back on. Here, I'm actually cancelling them. I'm getting them away from the sum. So I've changed this sum to 800 divided by 8, which hopefully you know is 100. Okay. Topic 5, substitution. Yeah, easy enough. Just put these numbers in instead of these. So we need to know that 5c means 5 times c. What is c? Well, c is 3. So just 5 times 3. So substitution, the answers are going to be numbers. Okay. E take away d, 15. Take away d is 8. So 7. I've written my own one here. If a equals 4 and b equals 5, what is a squared plus b squared? Easy enough. 16 plus 25, so that's 41. Remember, squaring means times in by itself. I know you're set at 1, so the chances are you will know that. Yeah, that's all I want to say. Yeah. Solving equations, we go from, well, let's just take one of each. One from each line. So on this line, the opposite of minus 1 is to add 1 on, so a equals 7. On this line, the opposite of minus 12 is add on 12. So 6c equals 60. Therefore, we've got a second step to do here because it's 6c, and that's to divide by that 6, and 60 divided by 6 is 10. That's that one. Let's now do k. All right, here we've got a third step, I guess. So we've come from 1 step to 2 steps to 3 steps. The third step here is the division underneath it all. And because it's all divided by 3, it's the divide by 3 that needs to move first. So the opposite of divided by 3 is times by 3. So I'm actually going to bring this one down here, if you don't mind. So 2x plus 5 equals, and the answer is no longer 7, it's 21. Now it's back to being a 2-step. Plus 5 minus 5. So take it away from there to make 16. And times 2, 2 times x, the opposite of times in by 2 is to divide your answer by 2. So x equals 8. And then let's take a look at this, which is, we've gone from 1 step, 2 step, 3 step to this, a particularly unusual one where you've got x's on both sides, a slightly different thing. Because here you're going to have to go, hang on, you need to come over and be on this side with the x's, but you need to go over here and be on this side with the numbers. So when I move the plus 2x over, it becomes a takeaway. And when I move the plus 1 over, it becomes a minus 1. So I end up with 2x equals 6. And divide the 6 by 2 again, so x equals 3. Slow, isn't it, this video? Oof. Right, let's start with some of the easier rules. So the rules are, if you multiply, you add the indices. If you divide, you take away the indices. Another way to write divide is as a fraction, still means divide, so you're still taking away the indices. You can only do that, mind, if the letter that that the indices on is the same. So here everything is y. So y times y divided by y. If they're different letters, that's a different thing, right? So, but look at the word, what it's asking you to do is just simplify. There's no answer here. It's taking two things and bringing them together with a single indice, okay? The third type that we can see here is this type here. And then this type here, we multiply the indices, where you've got a bracket and then raised to another indice. Then onto the sort of A and A starry ones, the sort of harder ones here, okay? The way I remember it again with indices is underneath, if you've got a fraction, the bottom is the root and the top is the flower or the power. So the power and the root. So for example here, that would be a cubed root of 8, which is 2. This would also be a cube root of 125, which is 5, because 5 times 5 times 5 is 125. That's why the cube root of 125 is 5. However, here, and the top number isn't 1, it's 2, so we've actually got a power as well. So we've got a power of 2. So we need to take our answer and square it. So the answer is 25. If a negative indice, try and remember that rule. If an indice is negative, it just means 1 over. Right, so ignore the minus because that's what's going to happen. We're now then left with the sum 4 squared. 4 squared is 16. So instead of being 16, though, because it's minus, it'll be 1 over 16. So the answer isn't negative, it's 1 over. And here you've got a mixture of kind of everything. So we'll do this one here. So let's do it in 3 steps. Ignore the minus. The first step is the root. This is a square root of 25, which is 5. The second step is to take your answer and have a look at the power. This is cubed. 5 cubed is 125. The third step is to look at the minus, which is the reciprocal, the flip, the 1 over. Okay, so the answer is 1 over 125. If you're not sure on like cube numbers, cube roots and things like that, so it's just having a little Google or a little look, what's 2 cubed, what's 3 cubed, what's 4 cubed, just to make sure you're happy with that. Fractions of amounts, easy, not saying anything. I think, divide by the bottom is 8, and then times that by the top, which is 24. So divide that by the bottom, and then times by the top. How to find a fraction of an amount. Operations with fractions. With adding and taking away, we've got to make the bottom numbers the same. So if we looked at this one here, I'd be going, right, okay, can I make 5 and 3 different denominators? I need the bottom number, the denominator, to be the same. They both have 15 in their times tables. To make that 15, I times it by 3. So I'm also going to times that by 3 to change that to that equivalent fraction. Here, to make that 15, I need to times it by 5, also times the top by 5. End up with 12 over 15, take away 10 over 15, which is 2 over 15. In terms of multiplying, much easier. Multiply the tops. 1 times 1 is 1. Multiply the bottoms. 3 times 3 is 9. And in terms of dividing, we use KFC or KCF or whatever. And we'll stick with KFC because it's easier to remember, which is keep. Keep this one the same, 2 over 3. Flip the second one. So instead of 5 over 6, it's 6 over 5. And change, C for change the divide to a times. Then you can just times the top. 2 times 6 is 12. And times the bottom. Okay, so KFC for dividing. Change that divide to a times and flip the second fraction over. Ratio, I'm not going, go on quickly, I will. Add, I think of this as Adam, which is add, divide, and multiply. So add those, divide that number there by whatever they add up to, which is 4, and then multiply. 4 times 2 is 8, and 4 times 3 is 12. Again, I wasn't going to say anything on that, but there we are. It's there now. 11, standard form. Yeah, so 8 times 10 to the power 1, 2, 3, 4, 5, 6. That's turned into a straight line. Sorry, don't know why that's happened. Whereas here we've got 4 times 10 to the power, and this time we jump in the decimal point down the number, not up. 1, 2, 3, 4, 5, 6, 7, 8. But down the number. It's a small number, so it'll be minus 8. If we are multiplying, okay, it doesn't matter if these are in brackets or not. It's what's between the bits of standard form. That's the important bit here. Then we will multiply the numbers first. 1.2 times 6. Then we will multiply the tens. 10 to the power 4 times 10 to the power 4. Well, we just said if we times the same thing, 10 times 10, we can add the little numbers. Dividing, 3.5 divided by 5. Right, you could do that as a little sum here. 3.5 divided by 5 is 0.7. So it's 0.7. And this is really tough. If you're dividing, we take away the little numbers, but it's not 9 take away 2. Like it's 2 take away 9, which is minus 7. This is a huge problem, this question. We really don't want this. The problem with here is, just like here, 0.9 is 9 times 10 to the power minus 1. This isn't in standard form, right? So, however, to make it, we would need to change the 0.7 to 7, like we changed the 0.9 to 9. But because we've made that bigger, like you, we had to take away 1. Well, we have to take away 1 here, but we're taking it away from -7. We have to make that 1 smaller because we've made the number 1. Sorry about that, guys. The video cut off there. So if there's a bit of a jump in this video, that's what happened there. So I was kind of here, I think. So we said that if we times in and dividing, we can do it in standard form. But if we're adding or taking away, like these questions here, adding standard form or taking away standard form, I think we need to change these to numbers. Okay, so what we've got here is 5.12 times 10 5 times. So if I times it by 10 once, it'll jump the point there. Twice over there. 3 times, 4 times, 5 times. So that's me timesing that by 10 5 times. Here, if I times that by 10 4 times, once, twice, 3, 4 jumps. Okay, we're taking them away. So again, I ignore that that's there. I'm going to line this up under here, starting with the 0 under that 0 under there, the 9 under there, the 8 under there, and the 1 under there. These are quite nasty take away. Add is easy, right? Take away, right? Don't need that actually. So I'm taking these away from each other. That's fine, that's fine. Here I'd have to borrow from the 2. 10 take away 9 is 1. Here, borrow from the 1 to make that 11. It's a bit messy. 11 take away 8 is 3. Again, 0 take away 1. I'm going to borrow from the 5 to make 4. 10 take away 1 is 9. And 4 take away nothing, that's that. And then put your answer back into standard form. How many jumps? 1, 2, 3, 4, 5. So that's adding and taking away standard form. I will go with some of these other ones. I would. Okay. Compound shapes, area and perimeter. Well, for perimeter, we're going to need to know all the sides. Okay, so it's worth probably working that out first. So if that's if vertically the total vertical is 15, but we only know a small part 6 here, then the other bit must be 9 in here. And similarly, horizontally, we don't know the total horizontal, but we've got an 11 horizontal there, an 8 there. So the total must be 11 add 8, which is 19. So perimeter is add them all up. 6 plus 19 plus 15 plus 8 plus 9 plus 11. And that answer there will be in centimetres. You could do that. I'm not going to waste time in this video doing that. For area, we could split either downwards, or I think I'm going to go across, and I'm going to call this the top rectangle A, and this B. And I'm going to say, right, the area of A is 19 by 6, and the area of B is 9 by 8. Let me show you where that comes from. 9 by 8. 9 long, 8 wide. Okay, work those both out, add those together, but that answer will be centimeters squared. I'm rushing in case this video goes dead again. So, okay, inverse, what that means is this, I guess. So the area of the triangle is base times height divided by 2. In this case, we don't need that. We only need the base and the height. 5 times 12 divided by 2, 60 divided by 2, so 30 centimeters squared. And we're told here the area of the right angle triangle is equal to the area of the rectangle. What is x? Well, 10 times what gives 30. There's no divided by 2 here. It's not a triangle. It's literally length times width, or base times height, whatever you prefer. So the missing coming from dividing the area by that. So 3 centimeters is the missing length there. 14, product of primes. Again, all I'd say here to remind you is your prime numbers are these. 4 is not a prime number. 6 is not a prime number. You look, neither is 8, neither is 9, right? Neither is 10. They are your main ones. There are, obviously, it keeps going, but you're not going to need more than those 5 to do these. So if I was taking a number like 900, I can look to divide by one of these, but I think the easiest divide is to divide that by 9 and think of it as 9 times 100. 9 then would become 3 times 3. These are both prime. We could stop. 100, you could do anything. You could do 10 times 10, or keep them both going. Or I might go, look, 2 times 50. At least with the 2, I know it's prime, and I can stop there. And then with the 50, I'll go 2 times 25. And with the 25, I can't do 2 again, but I can do 5 times 5. And then you write that as It doesn't matter what order you do this. I always do the smallest one first. So I start with the 2's, and there's 2 of them, times 3, and again there's 2 of them, times 5, and again there's 2 of them. It's not a bad one. Right, so let me start with LCM, lowest common multiple. Multiples are the times table of these numbers. So I think the best way to do this is literally to write your 12 times table. You know, we can stop there a minute. You know, we don't need to go too far because I doubt we're going to get that far. But then 18 times table, which takes a little bit more time. You might have to do little 18 add 18, whatever that is, add 18, and keep doing it. Okay, and we're looking for the lowest number that appears in both. So that one is 72. Now, with highest common factor, there is a different way slightly to do this, okay? I'd be tempted with highest common factor. I'm going to give something harder than these, really. Let's do 21. I'd be tempted with highest common factor to do product of prime trees. So that's that. But these are a bit easy because it's not. And that's 7 times 7. And then look what's common to both trees. So in the 21, there's a 3, but there isn't a 3 in this one. But there's a 7 in this one, which is also in this one. So I can kind of take that out. Okay? Just to show you that with 18 and 24 quickly, because I think that will give us a little bit more sense of what we're doing. 18 is that. So 3, 3, 2. 24 is 2 12s. 2 6s, and that's 2 3s. Okay, so the way you can use it here is there's a 2 in here, which is also in here, so we'll pull that out. There's a 3 in here, and there's also a 3 in here, so we'll pull that out. There's a 3 left here, but there aren't any 3s left here, and there's a couple of 2s here, no more 2s left here. So the only common thing I can pull out is a 2 and a 3, times those together, and that gives you your highest common factor. Some of you would be able to guess that, though, because what it means is what is the biggest number that goes into both those numbers. 16. Simultaneous equations. Ooh, right. Let's do a DSA one. Yeah, let's do a DSA one. This one would be an SSS, same sign subtract. I'm going to do a different sign. So we start looking here at the y's, okay? This is our first thing. On the top, I got 3y, bottom 1y. To make them the same, I need to times this one by 3. Then they'll both be 3y. So I'm not changing the top equation, but I'm tripling the bottom equation, all of it. Now that they're the same, I look here at the symbols. They are different symbols, different signs. So we're going to add these together. 9x, the y's eliminate each other, equals, and add those together as well. So x equals 45 divided by 9, which is 5. Go back to, look, I always say go back to one of the top equations here. Because this one's got a plus in the middle rather than a minus, I'd be more tempted to use this. 2x plus y equals 12. But we now know x is 5. So 2 of them would be 10 plus y equals 12. Take the 10 away from the 12, so y equals 2. Try the other ones. Algebraic fractions. I'm just going to check quickly how much time I've got left. I'm hoping it seems to be cutting me short in time. Let's have a look. Oh, look, I'll keep going. If it goes dead, it goes dead again. Right, can't actually see how long they're going to give me. So what you want to do here is make the bottom numbers the same again. So what I'm going to do here is go, look. And to make that 20, I'll times it by 5, but I also have to times the top by 5. To make that 20, I'll times it by 4, but I also have to times all of the top by 4. Okay, so what I end up with then is 5 times this, which is 10x minus 5, plus 4 lots of this, which is 4x minus 12, all over. And I can make it now one fraction. Because they're both 20 at the bottom, I can do that, equals 3. Then I need to take the 20 up there as a times. But also I can simplify the top. So 10x plus 4x equals 14x. And minus 5 minus 12 is minus 17 equals 60. Okay. The minus 17 will go over as a plus. So 14x equals 77. And then x equals 77 over 14. A quick check. 14 doesn't go into 77, so therefore you can leave it like that. If you had a calculator and did on your calculator, you'd work out, I think it's 5 point, is it? I don't know. What's 5 14s? 70. That's 5.5, right? So it is 5.5. If you had a calculator, great. But if you don't, you can leave it as a fraction by all means. Okay, 18. We're getting there. We're getting there. We're getting there. Nice one. Great. Right. Don't worry about the top row. 18 over 99. You know, if everything's recurring, it's just over 9. However, here, 521. Take away the digit that isn't recurring over a 9 for that because it's recurring, a 9 for the 2 because it's recurring, and a 0 for the 5 because it's not recurring. So you end up with 516 over 990. Same here. Let's do this one. 03, take away. This digit is not recurring, so you're taking nothing away. However, on the bottom, the 3 is recurring, so get a 9. The 0 is not, so get a 0. So it's 3 over 90. Here, 28. Take away the 2 because it's not recurring. And again, the 8 is recurring, so get a 9. The 2 is not, so get a 0. And I know I didn't give a question for the last one particularly, but just to mention to you, all of the formulas you need are in the front of your book. There is a formula sheet. So I think in this one it happens to be a cone. Happens to be, okay? Go and find the surface area of a cone in the front or the volume of a cone. Look at the formula and whatever numbers they give you, put, whatever they are. I can't remember, right? I can't remember off the top of my head, but in the exam. But get the numbers you need from the diagram, stick them into the formula, which is in the front of your book. Don't forget, you don't have to learn these. They are there on the formula sheet, and you are good to go. Good luck with paper